Unicorns today, for some reason, bringing us a geometry problem. Another one from my favorite geometry problem creator, Catriona, a math teacher from Cambridge that you can follow on Twitter or can support by buying her book. If I don't have to worry about the animations, I can draw it a little bit more neatly and present the question. We're given what we in the United States would call a right-angled trapezoid, although confusingly in England it's called a right-angled trapezium. But at any rate, it's a four-sided shape with exactly one set of parallel sides, and one of the remaining two sides is perpendicular to those parallel sides. In this specific trapezoid, the leg that's perpendicular to the parallel bases has length 3, and we're told that the area of the red triangle is 6 greater than the area of the purple triangle. The question is easy enough to state. All we're asked to do is find the length of the side that is not perpendicular to the parallel bases. And while the problem's fairly easy to state, it's certainly not easy to solve. In fact, I think it's one of her harder problems. You go ahead and struggle with it if you want. I'm gonna ask my dog.
Look for similar triangles.
Man, I should have known. It's always similar triangles. So which triangles are similar? Oh, I think I see it. The red one and the purple one are similar. Because look, these two angles are congruent because they're alternate interior angles of this transversal. And these two angles are congruent because they're alternate interior angles of this transversal. And if I have two pair of congruent angles, because the interior angles in all triangles must sum to 180 degrees, the third pair is also congruent. What I'm saying is the red triangle is just a scaled up version of the purple triangle. Maybe it's easier to visualize if we orient the triangles in the same direction. Okay, so we have these similar triangles. Where do we go from here? Well, it kind of makes sense to use the information that's given. We were told a relationship between the area of the two triangles, so let's start there. As you probably have seared into your head, the area of a triangle is just half the length of the base times the height. And that's because for any triangle, if you take two copies of it, you can form a parallelogram, which you can then rearrange the area of to form a rectangle whose length is the base of the original triangle and whose width is the height of the original triangle. At any rate, it seems like we're going to need the base and the height of these triangles, so I'll add those to our picture. However, if you're like me, you might look at this and kind of cringe that I'm using the same letter to define different quantities and just relying on color to differentiate the two. There's a quick remedy for that though. Because the triangles are similar, the length of the base of the red triangle is just some constant times the length of the base of the purple triangle, and the height of the red triangle is that same constant times the height of the purple triangle. And one more thing to notice, because this is a right trapezoid, the length of the leg that is perpendicular to the parallel sides is going to be equal to the sum of the heights of the two triangles. So h plus ch just equals 3. I recognize that our picture's getting a little bit cluttered, but there's one thing I want to do before I go cleaning things up a little bit. And it's recognize that what we're looking to solve for here is x. It would be nice if there was a way to express x in terms of the variables we've already defined. And it turns out we can. The way I'm going to do it is make x the hypotenuse of this right triangle. Note that the legs of this right triangle are just 3 and the difference between CB and B respectively. I think that just about concludes the geometry portion of this problem, but there's still some algebra left to do, so let me clean things up a little bit. At this point there's lots of letters and lots of equations and it might be a little bit overwhelming, but have faith, things are going to work out really nicely. It's not a bad idea to pause at this point and see if you can take the red and blue equations and combine them in such a way that you could determine the value of the hypotenuse of the right triangle pictured in green. The way I did it, if I'm being perfectly honest, was just to kind of start playing with things. My first inclination was to get rid of the halves, so I multiplied both sides of the equation in blue by 2. And then I noticed some commonality in the variables, so I grouped them on one side of the equation and factored. I then noticed that c squared minus 1 is a difference of squares, so it factors into conjugate pairs as c plus 1 times c minus 1, which I got really excited about because I noticed that the red equation, if I factored an h out, would leave me with a c plus 1 as well. Substituting the red equation into the blue equation, and simplifying a little bit, leaves me with a really nice expression. I say really nice because the left side of this equation is exactly the expression that we have representing one of the legs of our right triangle. What I'm saying is the legs of our right triangle have lengths 3 and 4, so either you have memorized that a 3, 4, 5 right triangle is a thing, or you apply the Pythagorean theorem to solve for the length of the hypotenuse is 5. As always, I want to end this video with the challenge question. Suppose you wanted to remake this question, but with different numbers. So instead of having the final answer be equal to 5, suppose you want the final answer to be equal to 13. Assuming we don't want any fractions, what would you choose for the height of the trapezoid? And what would be the difference in the area of the two triangles? I believe there's 2 different sets of numbers that satisfy the criteria. As always, I'd love to hear your feedback, questions, or solutions in the comments.